Welcome back to the deep dive. We've already looked at the first few chapters of the National Security Commission on Emerging Biotechnologies report, uh, prioritizing biotech, mobilizing industry, defense
Right,
applications.
building that foundation.
Exactly. So now we're diving into chapter 4. Out-Innovate our strategic competitors.
And this chapter, well, it really gets to the heart of maintaining that U.S. edge. It argues that, yes, we lead in biotech R&D now, but that lead might be slipping.
Slipping. Okay, so what are the warning signs according to the Commission? Where are we maybe falling short?
The chapter points to a few key areas. It's about how we treat biological data, the ambition behind our research efforts, and crucially, whether our safety and security measures are actually keeping up.
Right. So 3 big themes we need to unpack. Data as a strategic resource, these sort of grand challenges for research, and then protecting against potential harms. Makes sense.
That's the structure. First up, biological data, treating it strategically.
Okay, so biological data. When they say that, what exactly are we talking about? It sounds like more than just, DNA sequences.
Oh, much broader.
Yeah.
NIST defines it as basically any information from a biological system, structure, function, process, plus the descriptors, the metadata.
So that could be human genomics, proteomics, all the omics.
Exactly, and not just human. Animal data, plants, fungi, microbes, viruses. It's the whole biological spectrum.
Yeah.
Think of it like the massive text data sets that train large language models. Biological data is that raw fuel for AI in biotech.
Got it. A vast amount of info. And the report's saying the U.S. isn't really making the most of this fuel.
That's a core point, yeah. We apparently have huge untapped reserves. They mentioned like 800 million to maybe a billion biological specimens just sitting in natural history collections. A lot of their data completely unanalyzed.
Wow.
Meanwhile, competitors like China are actively using global public data while keeping their own data sets very close to the chest. That creates an imbalance.
A strategic imbalance.
Oh.
Okay, so the Commission doesn't just point out the problem, it proposes solutions. Let's get into Recommendation 4.1a, this web of biological data, the WOBD, Department of Energy leading it.
Right, the WOBD. The vision here is a single, secure place where researchers can access federally funded biological data. But it's more than just storage.
Well, so?
It's about interoperability, making sure different data sets can actually talk to each other, enabling advanced computation, complex analyses you couldn't do with siloed data. It's designed to be a real force multiplier for R&D.
So breaking down the silos, making the data work together.
Exactly. Initial steps are like assigning a national lab to manage it, getting NIST involved to set up the technical framework so data formats are compatible, like universal translators for data.
Okay, that sounds fundamental. Which leads neatly into the next recommendation, 4.1b, NIST setting standards for AI-ready data. Why is AI-ready the specific focus?
Because without standards, AI algorithms just can't easily process and learn from this diverse data. Right now, everyone kind of does their own thing with data formatting and structure. It's disconnected.
So NIST needs to create a common language, essentially.
Pretty much. They propose a two-phase approach. Phase I, first couple of years, is defining what AI-ready even means, consulting widely.
What would that definition include?
Things like making sure data works with the WOBD, being accessible via APIs within a year, having machine-readable metadata so it's reusable, standardizing formats for aggregation, including all the controls and outputs, and making the raw data available.
Okay, the nuts and bolts of making data truly useful. And phase 2?
Phase 2 over the next 3 years is about building up NIST resources, cybersecurity frameworks, hiring people, and then the really crucial part, working with funding agencies to actually require these standards for federally funded research, even updating procurement rules, the FAR.
So putting teeth into it, making it standard practice. Got it. Okay, next up is 4.1c, moving over to the Department of the Interior, a sequencing public lands initiative. This sounds fascinating.
It really is. The report points out we lack a strategic plan for collecting non-human biological data, despite having this incredible resource in our public land system, national parks, other federal lands, just teeming with unique organisms and ecosystems.
Untapped biodiversity.
Exactly. So this initiative suggests a 3-phase plan to systematically sequence and catalog the genomes of animals, plants, fungi, bacteria, you name it, across these lands.
Starting small, I assume.
Yeah, with a 2-year pilot, they'd select 5 national parks based on, their biodiversity, research potential, infrastructure, partnerships, even educational links.
Systematically mapping the genetic code in our parks. That's ambitious. The potential discoveries seem huge.
Absolutely. a potential treasure trove of biological information.
Okay, and the last one in this data section, 4.1D, NSF establishing cloud labs. What are those?
Think of them as highly automated remote access labs. Researchers could use state-of-the-art tools for experiments without needing the physical equipment on site.
So making cutting-edge lab work easier and faster.
Exactly. Reducing the manual burden, speeding up data generation, it sort of democratizes access to advanced tools.
Makes sense. Okay, let's shift gears to the second major theme, launching grand research challenges. This sounds like aiming for the fences, big breakthrough stuff.
That's the idea.
Yeah.
These are meant to galvanize the research community around really tough, important problems. Recommendation 4.3a kicks it off by proposing centers for biotechnology within the National Lab Network.
But don't we already have bioenergy research centers? How are these different?
The bioenergy centers are, well, focused more narrowly on biofuels and bioproducts, often early-stage R&D. These proposed centers for biotechnology would be broader.
Broader how?
Each of the proposed 6 new centers would tackle a specific, focused area within biotech. They'd be interdisciplinary hubs designed to support high-risk, high-reward projects, provide access to really expensive, specialized equipment that maybe university labs or small companies can't afford.
So concentrating resources and expertise.
Right. DOE's Office of Critical and Emerging Technologies would coordinate, and the labs would be chosen competitively.
Okay. Then recommendation 4.3b calls for a specific grand challenge, making biotechnology predictably engineerable. That sounds quite technical. What does it mean in practice?
Well, the report suggests current funding often favors safer, incremental steps. Predictable engineering is about getting biotechnology to a point where designing and building biological systems for specific jobs is reliable, repeatable, like traditional engineering.
Moving beyond trial and error.
Kind of, yeah. Making it more like designing a circuit than, say, breeding a plant through selection. The challenge needs an inspiring goal, something the private sector might not tackle alone because it's too risky or long-term. It has to be interdisciplinary, push progress in other areas too, and be really ambitious.
And they put a price tag on that ambition.
They recommend at least $5 billion over 5 years. The focus is on strengthening that make, model, measure cycle in biology.
Model, measure.
Yeah, designing the system.
Yeah.
Predicting how it works computationally, model, and then testing it experimentally, measure, bringing engineering rigor to biology. It'd need a lead agency, coordination with the NBCO, and involve philanthropy too.
So really trying to systematize biological design.
Okay.
In the third grand challenge, 4.3c, tackles biomanufacturing scale-up. Why is scaling up such a big issue?
It's often the valley of death for biotech innovations. The U.S. is great at discovery, but the report says we've historically underinvested in the fundamental research needed to take something from a lab bench to industrial production efficiently and affordably.
So brilliant ideas get stuck.
Exactly. The process can be slow, expensive, unpredictable. This challenge aims to fix that makes scale-up predictable, fast, and cost competitive.
How? What are the research targets?
It focuses on 4 key areas: the chassis or organism doing the manufacturing, the feedstocks it eats, the actual process technology and equipment, and the critical inputs needed.
Improving all the components of the biological factory, essentially.
Right. Success here would mean more distributed, flexible, resilient biomanufacturing. Less reliance on single points of failure.
And the structure for this one, similar to the engineering challenge.
Pretty similar. Congress designating lead agencies for each area, interagency coordination via the NBCO, and funding tied to hitting specific milestones and showing progress.
These challenges definitely sound like they could drive major leaps forward. Which brings us to the final, crucial section, protecting against the harms of biotechnology. With power comes responsibility, right?
Absolutely, and the report is quite critical here. It argues we need to get beyond blunt and reactive tools like just stopping research, moratoria, or relying only on lists of dangerous pathogens. It also points to fragmented government leadership.
What's wrong with the current tools, like moratoria or the select agent list?
Well, moratoria can cause big delays, potentially stall important work, and damage trust if they aren't handled well. List-based systems like the Select Agent program really struggle to keep up with how fast new risks emerge or how existing tech can be misused. Plus, the report notes we often don't systematically check if these measures are even effective.
And the fragmentation problem, different agencies doing different things?
Yeah, exactly. You get overlapping gaps. Think about oversight for high containment labs or screening synthetic DNA orders. Responsibilities are scattered.
Leading to inefficiency? Or maybe things falling through the cracks?
Both, potentially. It creates confusion for researchers and industry. And things like gene synthesis screening guidelines were largely voluntary at the time of the report, which is a clear potential vulnerability. A bigger issue is that for many agencies, biosecurity isn't seen as core to their mission.
It sounds like the policies just haven't kept pace with the science.
That's the core argument. Things like guidance updates for gene synthesis or oversight of risky research, DURCPEP, take way too long. The Federal Select Agent Program, they argue, needs a fundamental rethink for today's world.
So the big fix proposed is Recommendation 4.4a, create a whole new entity specifically for this inside the Department of Commerce. Why commerce?
The logic is that commerce already focuses on innovation, it has NIST for standards, and it handles certain security aspects. So it's seen as a good home, blending promotion and protection. This entity would work closely with the NBCO and those new centers for biotechnology.
And what would this new entity actually do? Sounds like a big job.
It is. 5 main responsibilities outlined. First, actively identify emerging risks. Continuous evaluation, analyzing disclosures, maybe a no-fault reporting system, having whistleblower channels, regular forums, being proactive.
Oh, okay, looking ahead. What else?
Second, fund R&D into better biosecurity and biosafety tools, using an ARPA-like model for high-risk, high-reward projects.
Like what kind of tools?
Things like building safety features into biological designs, biosecurity by design, using AI to assess risks of sequences or organisms, developing ways to handle novel research concerns, better risk assessment methods overall.
So innovating in safety itself.
Third, develop and promote best practices, standardizing requirements across funding agencies, pushing adoption of safety innovations, working on workforce training.
Makes sense. Getting everyone on the same page.
Yeah.
Fourth.
This is a big one. Consolidate and oversee the actual policies.
Yeah.
Modernize the Select Agent Program, enforce gene synthesis screening, update other rules over time. Importantly, work with other agencies where tech overlaps like cyber bio risks with DHS-CSA. Also, establish proper licensing for high-containment labs and personnel accreditation, and maintain strong links to law enforcement.
So becoming the central hub for policy and enforcement. And finally, the fifth responsibility.
Engage internationally. Work with other countries to improve global standards and best practices, share information and technical advances on safety and security.
That's a very comprehensive mandate, a serious attempt to build a modern framework. Okay, so wrapping up our look at Chapter 4, what are the absolute key takeaways for you?
Well, it really hammers home the urgency. To stay ahead, the U.S. needs to treat biological data like the strategic asset it is, make it usable, accessible, AI-ready. We need to be bold with research, launch these ambitious grand challenges to solve the really hard problems in engineering biology and scaling it up.
And underpinning all of that.
We absolutely need a modern, agile, well-resourced approach to biosafety and biosecurity. One that enables innovation while actively managing the risks. It's not an afterthought, it's essential.
Yeah, you can really see how interconnected these all are. The data fuels the challenges, and the safety framework provides the foundation of trust needed for everything else to move forward.
Exactly. It's presented as a package deal, really.
Mm.
All necessary components to secure U.S. leadership in the biotechnology race.
A really compelling vision. It frames this huge opportunity for the U.S. not just to lead the innovation, but also to lead in setting the standards for doing it safely and responsibly. Definitely gives you, our listener, a lot to think about regarding how this could shape our future. Thanks for joining us for this deep dive.